Hi everyone. So I just want to take these last few minutes to go over a few more features of OpenRefine that are going to be really useful for us when we are dealing with data. So we've gone over faceting via text, numbers, dates. We've also looked at a sort of simple form of regular expressions, which we'll elaborate a little bit more on next week, and how that can help us find things that would be, basically parse data in a way that would be very difficult and time-consuming to do by hand. The final thing that I want to look at is that I want to demonstrate is some of the reproducibility features of OpenRefine, and this is actually where OpenRefine, I think, has some of its greatest value, although, again, I think it's a very good program for many reasons. So what I want to point out here is that you may have noticed that as we are going along, there's this count in the background called undo redo that has been going up at certain points. Now, first of all, we should emphasize when that count increases and when it doesn't. So you may notice that as I remove facets or, for example, create facets, right, that actually that undo redo count doesn't change at all, right? Even if I select certain things, include them, right, it's not changing. And the reason why it's not changing is because when we do faceting, all we're doing is we're asking for a new view of the data. We're not actually transforming the underlying data in any meaningful way. And so as a result, we don't see any increase in the undo redo. What the undo redo does is it actually automatically generates a log of all of the meaningful transformations that we have applied to our data set. So for example, we see item 0 is creating the project. We see the text transform. This is my initial text transform when I made a subset of trip duration rows into numbers, and then the remaining transforms when I completed it on the rest of the data. My date transforms, the mass edit, that was when I updated that Central Park W to be Central Park West. And now we see that the creation of our has CPW column is another one. Now, why is this important? Well, first of all, one of the great things is that instead of having to rely on, an undo command like Apple Z, if we feel like we've quote unquote made a mistake, we can actually step back in our actions here and return the data set to a previous state. So if we're not happy with what we did, we can actually just move back through it or move forward through it as we want. Now, one thing to keep in mind here is that if I were to say revert the data to this state, and then I were to come back to and start doing work on it again, I would lose these other 5 steps, right? So it really does let us move back in time, which is pretty great when we want to be exploring and not worrying about what changes we made to our data set, quote unquote, doing the wrong thing. However, even more than this is that you may notice here that there's something called extract and apply. Now, if I click extract, you will see that each of the possible sets, each of the steps has been automatically selected, and hopefully you will recognize the data format on the right, which of course is JSON. So what this is this is a JSON expression of all of the steps that I have performed on my data set so far. Why this is important? Well, because actually what this does is I can copy this out of here and I can use it. I don't know why this always happens, that it's like a little bit too zoomed. I can copy this out of here, and now let's say that I have done all this work on this first 100,000 rows. I've created my has CPW, but that's still only a subset of the data, right? Well, I want to be able to do this on the next 100,000 rows. So the way I would go about that is quite simple. I might come back here. You can see this is the original project that I created. I'm going to come back to create project, choose files, and I'm going to go back to my main data source again. Click next. Okay, and this is just generating the preview, remember. And what I'm going to do is I'm going to change my selections on the preview page so that I get not the first 100,000 rows, but the second 100,000 rows. So I'm going to once again edit the file name here, project name, and say city bike second 100. Okay. Now, how do I make sure I get the second 100,000 rows? You might have noticed this first. If you didn't notice this first time, we have not just the loaded most, but the discard initial. So I've already loaded the first 100,000 rows, and happily, because of the way that OpenRefine handles headers, I don't need to worry about subtracting one or adding one. And now I can say, all right, and now load at most 100,000 rows. Okay. By default, like logically then, I am capturing the second 100,000 rows of my data set. So I can update the preview if I want. I can create this project. And now here's the really powerful thing. You can see that just as it was initially with my first part of the data set, the trip duration is text, the start time, stop time, those are all text. Sure, it wouldn't be too complicated for me to, come here and do an edit column and transform those cells, but how much better that I can come to undo redo and I can choose apply. And now I can paste in the JSON from my first file and say perform operations. And what you'll see is that in about 3 seconds or so, everything that I did in my original file that's meaningful, again, that has impacted the data, has been performed. So not only do I have the format transformations, but it is automatically applied. It has also applied in that my regular expression and created a new column with the true and false on it. So if I wanted to see how many entries are true in this case, I can go ahead and look at it. And of course, I'm only going to get, this is only going to be meaningful if I actually also do a text facet on start station name, right? But I see that, again, maybe not surprising that there were some entries from all of the ones that had that. But hopefully what you can see from this is that this gives us an enormous power when we need to work with large data sets and or repeat analyses over time, for example. So not uncommon that, there'll be a set of operations that you do to a data set, maybe a government data set, something that's released on a regular basis. By doing this work in OpenRefine and having that automatically generated history, you can easily apply it to the next version of that data without having to manually do it all again. Again, this is something that you can do in Excel, but it's a bit more effortful. I would say it's substantially more effortful, actually. And so it's really great that it's just built in here. Finally, one other thing that I want to talk about here is that there is there's an option here on the edit cells called cluster and edit. Now, this is not really going to be, hold on. Again, I have a sub-selection here I want to get rid of. So let's go ahead and make sure we have this. So cluster and edit is something that is not so applicable to this particular data set because I would describe this data set as actually being very clean, right? Basically, there aren't a lot of misspellings or anything like that. Now, without getting too far into exactly how this is doing it, this is basically using algorithms that try to find things that sound the same. So things that have kind of phonetic representations, similarities. And we can go ahead and go through these. The Metaphone is probably going to do better for us here. So this is actually using, it's using sounds. It's using word sounds to cluster these things. Now, again, we believe that these are all distinct, other than something like the Central Park West, Central Park W that we've highlighted. We wouldn't likely want to edit any of these to be the same. However, working through this is very valuable when you are dealing with data sets, particularly where the entries have been entered by hand. So one of my favorite examples of this always is the stop and frisk data set. Data sets, I should say, where there is an unbelievable number of ways that marijuana is spelled. Having these algorithms work to find things that sound the same but aren't spelled precisely the same way is really valuable. You can choose to merge and give a particular cell value so that you make sure that you are everything that should be classified the same way is classified the same way. So that's kind of the quick overview of OpenRefine. Again, we can export to a bunch of different formats here. And for your assignment, we'll be looking at doing some of these analyses on your own subset of the data. But other than that, I hope you all have a great weekend, and I look forward to seeing you next week.